51, and today we are going to present a topic text style transfer. Let's understand the problem first. Text style transfer is a growing field in NLP enabling changes in style, tone, and sentiment while keeping the original meaning intact. The challenges lies in creating models that handle multi-dimensional transformation like sentimental shift and formality changes with the real-world application ranging from customer service to cross-lingual communication. This technology bridges linguistic and cultural gaps, making communication more accessible. It enhances adaptability across industries like marketing, education, and international diplomacy by generating audience specific context aware text. Now, let's analyze why. We extended a 2019 multi attribute style transfer model using the T5 architecture, enabling flexible multi-dimensional style transformation. Key evaluation metrics include blue score, sentiment accuracy, and reconstruction loss to measure improvement over the baseline. We chose the 2017 paper because it provides a foundational understanding of content style disentanglement, which was crucial at the time. Which was really crucial at the time. But we noticed that in the subsequent research paper, it was proven that disentanglement isn't that necessary in order to produce style transfer. But in order to understand why this theory was disproven, we needed to know the base of it. That's why we chose the 2017 model. Now, we use dataset. Let's now talk about the dataset. We use dataset from Yelp and Amazon pre-processed to include annotation for gender sentiments and specific domains like foods or electronic. The both the data consist of these many data points and were divided into positive and negative sentiments. The FYelp dataset looked like this. The most important columns were these, which we wanted to use which we wanted to use in our transformer. And this is the example of how the data was populated. Similarly, for Amazon, these column was the most important one, and this is the example for the which was present in the dataset. We pre-process the data so that it could be readable by a transformer and convert it into a string. Over here, we have given a dictionary so that it is more readable. Now, let's talk about a baseline model approach. The baseline model uses an encoder-decoder architecture to separate content and style into distinct latent spaces. The encoder captures a style-independent representation, preserving core content while the decoder reconstructs the sentence with a desired style. Adversarial training ensures stylistic accuracy by using a generator to transform text and a discriminator to distinguish between real and generated outputs. Cross-alignment maintains consistent content across styles, ensuring semantic integrity. Performance is measured with blue score for content preservation and a pre-trained style classifier for style accuracy. Now let's talk about our model. Our first approach builds on the T5 model transformer-based architecture for text-to-text tasks, fine-tuning T5 for style transfer. It leverages its encoder decoder structure and multi-head attention to capture long-range dependencies and contextual relationship. The T5 encoder creates embedding that blends content and style, enabling the decoder to generate outputs in the desired style while preserving meaning. Curriculum learning improves generalization by training in phases from simpler to more complex example. Data augmentation techniques like paraphrasing and back translation further diversify the training data, enhancing the model robustness for real-world application. The T5 model leverages its pre-trained encoder-decoder structure with multi-head attention to generate contextually rich outputs. By fine-tuning it for style transfer, it captures both content and style effectively, using curriculum learning and data augmentation to handle complex transformations. Our second approach involves a custom transformer designed for this task. Tokenized inputs include explicit style annotation like gender, sentiment, and formality, providing detailed instruction for style transformation. The self-attention encoder captures word relationship and separates content from style, while the cross-attention decoder integrates content with the target style for precise control over tone and structure. The model is trained with cross-entropy laws to balance style, accuracy, and content preservation, enabling nuanced transformation with explicit control over multiple stylistic attributes. A custom transformer processes tokenized input with explicit style annotation, ensuring precise style control. The self-attention encoder captures content dependencies while the cross-attention decoder supplies the desired style optimized through cross-entropy loss for accuracy. Now, the matrix we used were the BLUE score. The higher BLUE score indicates better content preservation during style transfer. The style transfer accuracy uses a pre-trained style classifier to evaluate whether the generated output matches the desired style. In order to improve our model, we use these losses. The very first one being the reconstruction loss, that ensures the model can accurately reconstruct input text with no style change is applied. Adversarial loss encourages the generator to produce sentences that align with the target style. The cross alignment loss ensure content representation remain consistent across different styles. We added all three losses and created a total loss. The results, unfortunately, we weren't able to complete the training before this video submission, and that's why we were only able to create the training till fifth epoch, which produces really great result. And we will be presenting this in our final presentation when the entire model is completed. In conclusion, our work enhances communication for non-native speakers, bridging linguistic gaps and enabling industry-specific adaptability. By extending the baseline, we provide a robust framework for future advancement in multi-attribute text style transfer.